What function is equal to the infinite sum of all its derivatives? To answer this question, we'll rely on the fact that the derivative of the function e to the x is equal to itself. Let's take a look at the infinite sum of all the derivatives of e to the x. This is clearly not equal to e to the x itself because this entire right-hand side diverges off to infinity. To solve this issue, we will add coefficients in front of each term of e to the x to make this sum converge. The way we'll do this is by altering the exponent of our function to be x over 2. Because of the chain rule, every time we take a derivative of this function, it corresponds to multiplying the previous derivative by a factor of 1/2. So here is the infinite sum of all the derivatives of our function e to the x over 2. Instead, we can write it in summation notation and use calculus to evaluate the sum. We can calculate the sum of 1 over 2 to the n as n goes to infinity using the geometric series test. Plugging in 1/2 into the formula for the geometric series gives us that this sum is equal to 2. Notice how the bottom sum starts at n equals 0 while the top sum starts at n equals 1. We can solve this by subtracting the first term from both sides of this equation, which gives us that the sum starting at n equals 1 is equal to 1. Now we can evaluate the sum of all the derivatives. Plugging in 1 for the sum of our coefficients gives us that the sum is equal to e to the x over 2, which is our original function. Therefore, e to the x over 2 solves our initial differential equation.